Hello, everybody. I'd like to continue along. Now, up to now, what we've been doing in this class, I think I'll write this down. Up to now, we have been implementing the techniques you were supposed to have in CSC 103. In 103, the implementation was Python. In 104, the implementation is C++. Now, I know that in some cases, perhaps you didn't get as much as you should have in some of the in 103, but I hope you've caught up. It seems like many of you have. We've done so far, we have done the input and output, and we've done that for C in and C out, and also for files. We've done arithmetic statements. We've done the Boolean expressions. We've done all the versions of ifs we can think of, with or without else, with or without else if. We've done whiles, two different types, the do while and the while. And we've been talking about strings, arrays, and vectors, plus two-dimensional arrays. And along with all of that, we've had to talk about the types int, double, bool, char, and string. As well as void for a type of a function. So that's a rough summary of everything we've done so far, or at least a pretty large portion of it. How could I have forgotten? There's one more thing we did that's very important. Right after whiles, we did functions. And if you remember with functions, we went much further than you could in Python, because we had call by reference and call by value. So that is the techniques you used when you were in Python. Now we want to sort of expand what we're going to do. And the word that we're looking at is abstraction. The idea is to try to think in higher concepts. To give you an example, we had a homework on complex, but we looked at complex as two variables instead of one, a real and an imaginary part. Now I will eventually define a type complex, and we will use the plus sign to add them, not a function, as we did in the homework. The idea is now that the person using the program will be able to define complex variables and use the plus sign to add them and the multiplication sign to multiply them, and all the things that they would be able to do for int or double. Now, there's two people talking here. Well, I'm not two people, but there's two sides I'm talking about here. There's the person who's going to use the program, and there's the person who's writing the program. In our case, we're both. But think of it this way. The first thing you're going to do is define all that. You're going to be able to create these special types. Then you don't have to think about the details of them anymore. When you write your programs, you'll be able to think in terms of complex number and not necessarily in terms of the real and the imaginary. You'll still have to put the real and imaginary in the input. There's not much way we can avoid that, but it won't be as bad. Now, there are two most important concepts in CSC 104. The two I'm talking about are the class and pointers. We're also going to add one other thing. We will also be talking about struct and recursion. This material is the bridge from CSC 103 to CSC 225 and 325. So this is the way we're getting over there. And we have to talk about different things. Now at this point I'm going to talk about something pretty, well, I think easy, but you might disagree. I'm going to talk about the idea of a struct. Basically what we're doing is we are defining a new data type made up of other data types. We're giving it a name, and fields, what you can think of as parts of the type. This is sort of a junior approach of class. It's not class, but sometimes it gets confused with it. This is an easier part. What we're trying to do here is we are abstracting items that go together into one type. Now, the first example I'll give of this. Example. A person's name. Now, we can think of this as it consists of a first name, a middle initial, maybe, and a last name. And I agree that there could also be a title like 3 or junior or senior, but I'm going to leave that out for now. Well, fine, we have the name, but they're sort of spread out. There's 3 pieces to it. What I want to do is define a type that covers all 3 of them. So what I'm going to do is say, I want a struct, which I will call person, and I will give that person 3 pieces. He will have a string that is his first name, one for his last name, and one for his mid-initial. And I will be able to use well, pardon me, if I write person first, then I will be able to write first dot first name and first dot last name and first dot mid init. Now, I think you've seen some of these dots already with the strings, for example. We've used them a lot. And it's the same kind of concept. And we'll be carrying it over into class, because string is a class, because it adds more. All we're abstracting here is the pieces of the data type. We're not abstracting how we work with it, how we write it, how we add to it, how anything like that. We're just abstracting the data, putting it all together in one place. For example, if you had an array of person, it would be neater to do it that way than to have a separate array of first name and a separate array of last name and a separate array of middle initial. They hold together better this way. Now also sometimes it's necessary, because when you're passing these items to a function, it's much easier to pass one item of type person than 3 items of 3 different types, or 3 strings. Now, I've written a couple of programs on this, and let's go and look at one. So the first one, I hope, is simple, but you probably won't agree with me, so we'll see what happens. I can only hope that it won't be that hard for you. All right. So just as I said before, I've defined a struct person. And now, in the main line, I'm going to define a list of 3 people. That's an array I'm defining, and every element in that array is a person. And what I'm going to do is read in 3 people and print them out. I'll show you how it works first. Well, actually, I didn't do very well the way I set this up, so let me put a cout in. Cout, input, last name, on a line, first name on next line, and I can't do that. I can't break it in the middle of that. So the only way I can do it is to continue by putting the quote here, and then I continue, by a middle initial on a third line. Use star if there is no middle initial. Now, unfortunately, I had to do that. The reason I had to do it is because in the input that we have, it won't take it any other way. I'm sorry to say. It blew up on me. It didn't do what I wanted, and so I had to go and do it this way. So it works fine, but we have to do what we have to do sometimes, and that's what I had to do here. And let's see, I'll put the /n in, get me off that line, and then I'll close that, and that'll be the input. So let's see what happens now. Okay, I'm going to run the program. So it tells me what to do. So I'm going to try one. I'm going to try Mr. Adams, John Adams, and he doesn't have a middle initial. Now, I wrote it out in a different order. Watch. John Adams. Now I'm going to put in a second person. Let's say Roosevelt. R-O-S-E-V-E-L-T. Franklin. D. And now I got Franklin D. Roosevelt. And on my last one, I'll put in, let's see, Meade, Margaret, asterisk, no middle initial, and get Margaret Meade, a great anthropologist, in case you don't know. Now, look what I did. I read the L name of the first person in the list, the F name of the person in the list, and the middle initial of the person in the list. Then when I outputted them, I changed the order. I wrote out the first name, and then I put a blank after it. Then, if there's a middle name, in other words, if the middle initial doesn't equal an asterisk, I printed out the middle initial and followed it by a period and a blank. Otherwise, I didn't do that. Remember John Adams. Then, in any case, I printed out the last name. Now, the point of this is not that this is a brilliant program. The point of this is that you should get the idea of how I'm getting to the pieces. Notice, person becomes a data type that you can use to define variables, just like int and char and string and double. You have defined a new data type. And when you want to get to pieces of that data type, you have to use their field names. These have 3 fields and a dot. Now, I hope that that's not too hard an example, because the next one's going to be much harder. But let's just put this in. I'll put this over there for you. And it'll go into here. So I'll put it right here. Now, my second example is going to be the following. Example. I want to read a list of names and telephone numbers. Each entry will have name on one line and telephone number on the next line. Now I can show you what that looks like. Well, I can't. I didn't bring up the right thing. Pardon me. There's what I have. So Ronald McDonald, Ivan Romanoff, Alfred E. Newman, maybe some of you know him. Elmer J. Fudd, I suspect a lot of you know him. Mortimer T. Snerd, Lucy M. Ricardo, M. for McGillicuddy, John Q. Adams, John F. Kennedy, Ulysses S. Grant. So I have a few of these to play with. You'll notice that I was strict. There's always a comma after the last name and one space. So the form of the input, so in form is last name, comma, one space, first name, blank, mid, init. If it's there, it might not be there. And then on the next line, I have the, 10-digit phone number. The 10 digits including the area code. Now, I'm not going to put that in as a number because it's too large. And I wouldn't be able to begin with 0 in case I had to. So I'm putting that in its pieces. It's going to be a string, and I'm going to take it apart. So what I want to look at here is we will use struct, some string functions or methods. I'll use the better word. And actually, I think that we'll do file input too. So several those last two things are things you've been playing around with. Although maybe and maybe not, but you're supposed to have been playing around with them. So this might give you some more reinforcement in that. That's part of the reason I'm doing it. So let's look at the program. I got to go back here. I got to save this. And now I'm going to bring up the second program. Oh, one other thing I want to say before I do that. We're going to read a list of names and telephone numbers to create a directory, let's say, with the numbers in it. And what I'll do after I do that, I will search the list for all entries with a certain area code. Just for the fun of it. Obviously, I could search it for names, I could search it for a lot of things, but I think in this case I used area code, but we'll check. So let's look at the program. It's the second one here, names and telephones. And I was afraid of this. I have to bring in my source file. There. I got a lot of things at the beginning. Oh, I should add, there's one other thing I wanted to talk about here too. Besides these, I also wanted to bring in vector, because that is something else we've been playing with. So now let's see what we're going to do. Now there's the whole kit and caboodle up at the top there. And now let's look at this structure. This is a little bit different. I still have the last name, first name, and middle initial. Then I have the area code, the exchange, and the last 4 digits of the telephone number. So like 401-865-2635. And again, even though I use the word number, those are all strings. So now let's see what goes on. I was going to write that function. I changed my mind. So I wrote a void read function, and I wrote a void write function. And I just wrote a little main to take care of it. I decided I was going to make the list a vector, not an array as I did in the previous one. The reason is I don't want to take a stand on how big it will be. Frankly, I don't know. I typed those things in and I didn't count them as I was typing them. I don't know how big it is. And a vector allows me to do that much better than an array. But that means, of course, you have to remember the vector rules. Now, I keep saying this, but I want to point out to you. You want to find out what's going on with something? All right, I go to my browser and I say vector in C++. And I get out, you can either go to the basics of C++, or you can go to the reference, whichever makes most sense for you. The reference, well, this took me to a piece of the reference, not the full reference. So I'd rather get the full reference. Here it is. And this shows you each of the things that you can do, the functions, and if you click on one, you get an example. And you can do the same thing for strings. I already did it, in fact. Right here, this is string, but I actually had several, I had more of it there, other things. So you don't have to memorize it. You can find it if you need it. Look at examples. That's the easiest way to understand it. That's me speaking. Maybe you learn it in a different way. So let's go back and look at what we're doing. I'm creating a vector, a list. The list is empty at this point. Each item in the list is an entry. Entry is a data structure. It has 6 pieces to it, 6 fields. That's okay. They're all included in that one element, the entry. So this is if you looked at this, you might think it's a two-dimensional array with 6 columns. But we don't have to think of it that way. We have names for each of the pieces. Now we go down. I'm going to read. I have a line 1 and a line 2. I think I actually didn't need line 2 in the main line. I got my file, and I have my usual while get line 1. Once again, that does 2 things. It reads a string into line 1. It reads the entire line. And if when it goes to read it, there's nothing there, then it comes back false and you don't go into the loop. So it detects the end of file when it tries to read something and it can't read it. So let's see what we're doing. I read the person into line 1. I push the person into my list. I have to push back, remember. And then the size is how many out entries there are in list. That's one of the methods for a vector. And I say if the area code is 617, which is somewhere in Massachusetts, I believe, then write the list I. And that's it. That's all I want. Now my functions. Read. First of all, remember, if you send in an IO stream, or IF stream, pardon me, or an OF stream, you must send it by reference, not by value. It needs that ampersand, because otherwise it can't figure out what to do. And the ampersand can go in front, after the IF stream, or before the inval, just as long as it's in one of the two places. Then I'm passing in entry. Now, look at the advantage of this. That's 6 items I'm passing in, but only one input variable. And then I'm passing in string line 1, which I read up above. You notice I don't worry about it being changed because I'm not reading it down here. Pardon me, I have a certain friend that wants to have a little time here, so you might be able to see that it's a cat. And she does insist on being petted. Now, we'll go down here and look at my read. I'm going to use find. So what you really have to do is understand find. And there's 2 versions of find. There's the one that has 1 element and 1 argument, and the one that has 2. What find is you can ask it to locate something within the string. So if you remember, I had set it up so that there was a space after the first name and the comma. So I tell the computer, tell me where the space is. Now I probably should have said the comma, but it didn't occur to me until later. Then I say, okay, let's say the space is at location 6. Then there are 6 characters in front of it. So I want to start at 0, and I want to take those 6 characters. Now I have a feeling that okay, you notice I said position -1. That's to take care of the comma. If there are 6, take Adams, ADAMS, comma, blank. So I have to take, the blank is at location 6, and I have to take the first 4. I think that's right. Oh, it's at location 5. I forgot to start counting at 0. So let's see what happens now. Or 6, pardon me. I did get it right. I've taken the substring. Now, this is another version of find. That's very important. Unfortunately for many people, find does not look across the string. If you ask it a second time to find the space, it finds the first one again. So you have to tell it, I don't want to start at the beginning. I want to start at wherever the other string was, wherever the other space was, that was that position, +1. So over here I say, find the space, but start 1 past the last space you found. So it's pos +1. It's 1 past it. Now that takes out the line, the first the first name. I move position to one past that, wherever that was, wherever I found that quote, and then I look at the mid initial, and it's the last item on the setup. So it's the length minus 1. Then I get the second line. The area code is the first 3 digits. So start at 0 and have 3 digits. The exchange is the 3 digits after that. So start at location 3 and give me 3. The last 4 is the 4 places after that. So start at 6 and give me 6, 7, 8, and 9. Those are substring. You need to make sure you understand that. Now, I go back. By the way, if you'll notice, I put the ampersand on person so that any changes I make will be made. Now I write. Start a person entry. Name. Telephone. Name. Person, last name. I didn't bother with the middle initial. I ignored it. Then, telephone. The area code, dash. The exchange, dash. The last 4. And then end it. And then say, in the person entry. So there's a lot of little playing around with things. It's all that nuisance stuff when you have input and output. You just can't avoid it. And now let's see if it runs. All right, it says that I have these entries that are in 617. So let's see if the machine is correct. John Q. Adams. Oh, I did put the last part, the Q in. I thought I hadn't, but I did. John Q. Adams is in 617. So is John F. Kennedy. So is Charles Emerson Winchester III. Well, I don't have the third there. And so is Mary Baker Eddy. And they're the only ones in the 617. So it picked out the ones in the 617, which is what I was asking it to do. Now, how did I get that middle initial in? Well, I got it in. I think I must have just... It's there. It must have been listed as part of the first name or something like that. I'm a little surprised. I didn't think I put that out. And there may be something going on here I didn't notice. But it gets us the idea at least. And that's what I wanted. That you get the idea of how it's done. So, that is struct. Struct is important, but it's not as important as class. The purpose of struct very often is so that you can pass something easily to an array, to a function. You don't have to pass the pieces of it. So that is a good reason to use it. So here's my program. Here's my input. Get that up. So Control C. This is the input. Control V. And last but not least, this is the output. And now I have to go here. I do think there's something screwy going on getting that middle initial. I think I put the middle initial in with the first name or something like that, or the last name, which I shouldn't have done, but I didn't notice it till just now. So that's what you got. The thing I want you to take from this is how you handle struct and all this idea of the fields, the dot something. Plus, reinforce your knowledge of strings and vectors by looking at the methods I used from those two items. Because we're going to be using the same kind of dot notation when we do class. Now, I think I'm going to stop here for now, and very shortly, probably tomorrow or the day after, I'm going to bring in the class. I know you have a fair amount of work to do right now, so I won't throw in a homework at you at least until Wednesday. So, good luck, and I hope everything is working fine for you. Bye now.